And I believe this one does too, so it's our lucky day. Okay, so lots going on here. Okay, so let's get through it. Hopefully we can. So number one, x squared greater than 8x. What's going to be your strategy with inequality number one? X squared greater than 8x. Get 0. Kids, you gotta have 0. If you're doing inequality, you gotta have 0. All right, then what? Factor how? X minus 8. Very good, Jake. Then I can go to my number line. Where will my dots be on my number line? At 0 and 8. They will both be open dots. Remember, when there's a plain X, it's a 0, right? Now what do? Figure out where I'm shading by plugging in something. Now, I love 0, but I can't use 0, so I have to pick a different number. So maybe what? 1. So if I use 1, which is in here, I would have 1 times negative 7. Is 1 times negative 7 bigger than 0? Nope. So I don't shade there, so I'm going to shade the outside. And my answer is negative infinity to 0 or 8 to infinity. That seemed pretty easy. Let's look at the next one. As I copy it, I'm going to move everything over to get a 0. Are you okay with that?
Yeah.
What? What about this?
You factor by grouping?
Well, I would love to factor by grouping, but look what happens when I try to factor by grouping. It doesn't work because what has to happen? These gotta match, right? These have to match, they don't. So factoring by grouping isn't going to work. So what do you want to do instead? Synthetic division. And we're going to use factors of 8. So what do you want to try? 2? 2's not going to work. 1 will. Let's try 1. I'm pulling rank on you because I want to get through this whole sheet. There it worked, right? 1 worked. You okay? All right, now what? 1 worked, great. Now what? What's left is this.
Yeah.
And that factors into plus 2 plus 4. Now be careful. How many dots are going to go on this number line? 3. Kids, it's an X cubed. 3 X's. I know I'm going to have one at negative 4 and one at negative 2. Where is the other one? At 1. That's a dot. If it gave you a 0, it's a dot. Which means your third factor is X minus 1. So here are the factors. There are the dots. Now I just need to shade. By the way, those dots would all be colored in, right? So I can use 0 this time. 0 is right in here. So that's where I'll be checking. So 0 plus 2, 0 plus 4, and 0 minus 1. Did I get an answer less than 0?
Yes.
Yep. Shade it. Shade it. So negative infinity to negative 4, or negative 2 to 1. You okay? Everybody on board? All right, one more inequality. Oh no, there's another one over there. Next one is one that's a little bit more complicated. Do we remember how to do this? Subtract the 2. We always want to have 0 when we're doing inequalities. We almost always want to have 0 anyway, but certainly when we're doing inequalities. Okay? Now what? Lauren?
Maybe 2/1 and then you get the common denominator.
Exactly. So x plus 4. Now, do not lose the denominator. We need to keep the denominator going because it's going to give me a dot. So my denominator is x plus 4. So I have x minus 3, be careful, minus 2x minus 8. So negative x minus 11. Is that right? Now, I know I'm going to have 2 dots on my number line, and one of them is going to be at negative 4. That's easy. I always get confused with all those negatives up there. So I will over to the side actually work it out. Set it equal to 0 and solve it. So it looks like that other dot is at negative 11. Is that okay with everybody? Now, watch the dots. I know it's an or equal to, but the denominator can never equal 0. So that cannot be closed in, but this one should be closed in. A dot that comes from the denominator can't be 0. So it can't be negative 4. All right, I'm gonna pick 0. 0, is out here, would give me negative 11 over 4. Is that bigger than 0? Nope. Don't shade it, shade this. So my answer is negative 11 to negative 4. That wasn't too bad. How are you with that one? Are you on target there? You okay with that? Now this next one is not an inequality. It's an equation. What do you think about that? What do you think we should do? Okay, so she says we have to factor this. And almost always, take a clue from the problem, almost always, those factors are going to be these factors. Now, it's an almost, that's not a hard, fast rule. Usually they're rigged up that way. Just take a minute. I think it is this time, right? I think that's right. So there we go. Now we have the factors. Wouldn't it be great if all those denominators matched? Because then we could move on from there. So let's make the denominators match. So what will our common denominator be? That?
Yep.
So this one needs an x minus 2. This one needs an x plus 1. And oh man, this guy needs both, right? That is a 4-piece problem. So every piece has to have the common denominator. So now what's left? Well, let's see. Looks like we have x minus 2 plus 3x, x plus 1, equals 4x minus 2x plus 1 plus 3. Is that okay? Well, it's a heck of an equation, but now it's easy. We just have to do the work now. So x squared minus 4x plus 4, I'm gonna FOIL that.
Why don't
3,
we-
x squared plus 3x, what?
Why don't we keep the bottom on this one?
You don't need to, you can multiply both sides by the denominator and they cancel out. In an equation, that's completely legit, and in inequality, it's not. Oh, I guess, hurry up, leave your phone here, phone must stay. All right, so now what am I gonna have here? Well, if I FOIL that, I get x squared minus x minus 2. So it's 4x squared minus 4x minus 8 plus 3. Now that's a total disaster, but does it look okay to everybody? So 4x squared minus x plus 4 equals 4x squared minus 4x minus 5. Oh, this is gonna turn out way easier than I thought. What happens to these guys? They're gone, so I'm not gonna need to use the quadratic formula or anything. Looks like 3x equals -9. Did you get -3? Did anybody get -3? You were working faster than me. And -3 is not extraneous, so there we go. Some math teacher somewhere wasn't me, put a lot of time and effort in making that work out. All right, E is a calculator problem. E is a calculator problem, and here is why. You can go ahead and subtract the 2 over if you want. I'm not going to, but you can. The problem is you can't get rid of that denominator, and it's gonna have an x cubed in it. So you're not, when you get a common denominator, that'll be an x cubed. And so there's gonna be no way for you to figure out where to put dots on the number line. So I'm gonna graph this as one equation and this as the other equation. They're going to cross each other somewhere, and I will look to see where this one is above my line. 2 is just gonna be a line. So I think I've got a standard window here. And I'm gonna change my equation. To x squared plus 8 divided by x, and then 2. Give me a graph. My pink line is y equals 2. And my purple line is something like this. So this is the purple right here. Did anybody else get something that looked like that when you graphed it? Now, you want purple to be higher than pink. That's what you want. So where, right here is where purple equals pink. So let's find that. We can find that second calc intersect. 2.33. Does that sound right to someone else? Now, there's no points of intersection otherwise. That's it. That's the only one I have. So I need to put down all of the X values where the purple is higher than the pink. Would you agree it's all of this? So it's everything to the left of that point? Would you agree with that? So negative infinity to negative 2.33. It's an or equal to, so I'm going to put a bracket on that 2.33. Now, this is an asymptote. Look at your problem. Can x be 0? Nope. So that's an asymptote. This part of the picture, purple, is not above pink. But what about over here? Isn't purple always above pink over here? So how would I express that? It's this or what? 0 to infinity. Isn't it everything on this side of the y-axis? So here's where x is 0, and then everything to the right. Now, if that procedure confused you, then you could subtract the 2 over and graph that. And if you did that, then you wouldn't get a picture like this. You would get, I don't know, you'd get something. And you would need to find where it crosses the x-axis, right? And then where it is above the x-axis. If that's the strategy you're using. Answer will be the same. That picture's wrong. I don't know what the picture looks like, but that's wrong. But the answer you get will be the same. So you could do that either way. Graph it with both equations or graph it with one. Okay, anybody have a question about that? Okay, 2 is our big graph problem. So our function, our equation that we are graphing is this. Okay, so what do you want to do with that guy? Factor everything. So what do you notice about the top? And let's do that. So the 3 has to stay. Please don't lose it. The 3 stays. But then x plus 5 minus 2. Keep an eye on me. Don't let me screw up. And what about the denominator? X plus 2, x minus 2. So it looks like we're going to be left with 3x plus 5 over x plus 2. Is everybody with us to this point? All right, let's start graphing it. I'm going to fill in all the stuff. So the list is there. You won't have to remember the list, it's there. So what do you know? Okay, we know we're gonna have a hole because how do we know that? Because we cancel. And when we cancel, it's called the removal of discontinuity. And we have one at what? What's our x value? 2. And our y value will be 3 times 7 over 4. So 21 fourths, which is a little bit bigger than 5. So 2 comma 21 fourths is my whole. Perfect. Now what?
Vertical A.
I'm going to have a vertical asymptote where?
-2.
At x equals -2, because vertical asymptotes come from the denominator. There cannot be, x cannot be -2. That's a vertical asymptote. If you say this word, it cannot be, that's a vertical asymptote. Jake?
Horizontal asymptote that y equals 3.
Y equals 3 is my horizontal asymptote. Because we get that by looking at our powers of x here, boxing it in. 3x over x. Good. What else?
X-intercept at, -5.
Exactly, Lauren, an x-intercept at -5, because x-intercepts give me a value of 0. If you let x be -5, y is gonna be 0. They come from the numerator. What makes the numerator that fraction 0? That's an x-intercept, -5. All right, and then we got one more. What do we need?
So y-intercept.
Our y-intercept, so we're gonna let x be 0. So if x is 0, it looks like I got 15 over 2. Is that enough to produce a picture? Oh, I think so. It has a reciprocal function shape. So there's one arc. Would you agree with that? And then the other one is down here. Kids, I'm not trying to destroy your life. You're going to get a normal picture to draw. This is normal, okay? So make sure you know how to find all that stuff and you're all set. That's what you're gonna have to do. You good? Okay. All right, find the end behavior asymptote. Number 3, what do we do for end behavior asymptotes? Yep, we just divide. You could use long division, but that would be crazy in my opinion. Let's use synthetic division. It's so much easier. And assuming that I divided right, where is my end behavior asymptote? Y equals 2x plus 2. The remainder doesn't count. 2x plus 2. Everybody okay with that division? Putting a 3 in the box, doing the division. What are the excluded values? Where do those come from? Your denominator. So you probably want to factor your denominator. So it looks like for the first one, when I factor the denominator, I would get this, wouldn't I? So the excluded values are 0 and -4. How about B?
X minus 3, or x plus
Watch
3.
it, look at it carefully. Look at it carefully. None, there aren't any. Nothing real. Now, we're talking about real numbers now, no eyes. Nothing real will make that denominator 0. Would you agree with me? You're squaring and adding 9. It's not gonna be 0. So there are no excluded values for that one. What about for the last one? What's the excluded value? 0. X can't be 0. We kind of graphed it earlier. There's an asymptote at 0. An asymptote at 0. Okay, are you guys doing okay? All right, all we have left to talk about are these word problems, so here we go. Warren is creating a box to hold the cross-country memorabilia. Okay. The paper is 24 by 30. In order to hold her stuff, the box must have a volume of at least 1,000. If she cuts congruent squares out of each corner, folds up the flaps, how big must the cutouts be? What is the domain of this problem? Okay. Tell me your thoughts. What are you doing? When I'm not standing up here talking, and you're on your own to do this problem, what are you gonna write down? Okay, so, I'm gonna start with a picture, she said. Not required, but certainly perfectly wonderful. I love to draw pictures, helps me visualize. The paper is 24 by 30. So here's the situation. It's one of our regular boxes. Okay? Now what?
What's the equation?
What would that be, Peter?
24 minus 2x, and 30 minus 2x, and x, and then greater than or equal to 1,000.
Perfect. This is another one that's very similar to the one we did a minute ago on our calculators. When I do this, I like to graph this as one equation and this as another one. Look where they cross, figure out where this is higher than that. If you want to subtract the 1,000 over and graph one equation, that's perfectly okay too. Now, before I go to my calculator, what is the domain of this problem? In other words, what is my x min and x max? That's a question, so we need to answer it. What is 0 for the minimum and 12 for the maximum? Now, as far as my y's go, my volume, the minimum is gonna be 0, and I don't know what the max is, but it's gonna have, if I'm graphing this, it's gonna have to be more than 1,000. So I might make it 1,500 just to see what happens. All right, let's see if we can answer the question then. This is my domain. My domain would be 0 to 12. That's your domain to answer that part of the question. All right. Here we go. Oh, hey, I did a good job picking my window. That looks nice. If you're doing it with two separate equations. Is that what yours looks like? You guys that are just sitting there watching me, oh my gosh, I want to smack you. Okay, now listen. Okay, every morning, I walk, well, it used to be every morning, walk through across the balcony, and Jake and his buddies are out there playing basketball. So I stand there on the balcony and I watch. Okay? Now what's gonna happen when I go out on the court if all I have done is watch? It's gonna be terrible, right? So you guys need to work with me. You can't just watch me. Watching doesn't cut it. You gotta do it. I know you're bored out of your minds. You have a test next time. So get on board and start focusing. Okay, so this is 1.88 for that x value. Some acknowledgement would be nice. Yes, no,
Yes.
sort of, thank you. Robbie, I appreciate your enthusiastic yes. And my other one, I got 7.56.
Yes.
Thank you. So now I gotta somehow get an answer out of that. So these are the places these are the size of the corners that will generate a box that's exactly 1,000. I want to be at least 1,000. So that means 1.88 to 7.56 with brackets? Now, if it said less than 1,000, you need to be real careful here. Less than 1,000 would be this right here and this right here. Would you agree with that? So nobody has a problem with the first part. Less than 1,000 would be 0 to 1.88. Or 7.56, here's where the trouble comes. Where does this end? No, it doesn't end at infinity. Where does it end? It ends at 12. 12 is the last x value you can have. So if the problem were less than 1,000, then it would be 0 to 1.88, and 7.56 to 12. Okay? I promise, we get through these three, I'll just shut up. Because please hang with me for these three. All right, Bob likes lemonade, the water, Max likes it. What will be the percentage of water in a pitcher if Bob dumps in 18 ounces of his lemonade and Max contributes 28 ounces? This one's a little different than the other ones we did. Let's see if we can figure this out. What's our general format? Amount times percent plus amount times percent equals amount times percent. So let's fill in everything that we know. So here's Bob, and here's Max. So Bob likes lemonade that's 0.27, and Max likes lemonade that's 0.15. Bob dumps in 18 ounces. Max contributes 28 ounces, which, oh, by the way, means what's this? 46. Aren't these two being mixed together to get the end result? What do I not know? What that percentage is right there? Can I figure it out? I sure can. Let's do it. I got about 19.7%.
I got 0.197.
Yeah, 19.7%. Yep, perfect. Perfect, that's what I got. Thank you, Lauren. For doing it yourself. Now, that problem seems different to me than the other ones we've had, but the format is just the same, right? The variable's in a different spot, but it's the same kind of setup. Okay, Henry can complete the assignment in 6.5 hours. If Sean helps them, they can get it done in 4 hours. How long would it take Sean alone? All right, let's set up with that one. Yep, so 1 over the first guy alone, plus 1 over the second guy alone equals 1 over together. So what are our numbers? 1 over 6.5. 1 over x, because we don't know Sean alone, but we know this is 1 over 4. life would be perfect if we had a common denominator. Let's make our lives easy. The common denominator needs a 6.5, an x and a 4. So
26.
this one's gonna need a 4x. This one's gonna need a 4 and a 6.5, which is 26. That's 4 times 6.5. And this one needs a 6.5x. Now, are all of the denominators the same? Yep, they all have a 4, a 6.5, and an x. Here I just combined the 4 and the 6.5. So 4x plus 26 equals 6.5x. How long does it take Sean alone? 10.4 hours? Everybody okay? Perfect, wonderful, hunky-dory? I don't know about hunky-dory, but. All right, one more. What's happening in this last one? Math department wants to minimize the amount of poster board needed for the next math league announcements. We have to have 144 square inches of print material. Okay, so this is one of those deals where here's the print material and it's 144. And it's surrounded by borders. Left is 1.4. 2 is top. Bottom and right are 1.75. Now, does that picture make sense to you? Could you draw that picture on your own? Yep. So our job is to find the minimum area of the poster. So in other words, this guy right here, this is the whole poster. I want that to be the smallest it can possibly be. Okay? So I'm minimizing the area. Well, how do I find the area of a shape like that? Length times width. So let's look at the length and the width. Now, across the top, remember, this is 1.4, and this is 1.75, and then I have this guy right here. So 1.4, that, and 1.75 is across the top. What's that? No idea. I'm gonna call it X. 2 is this up here. This is 2 is the margin at the top. Now, this is the 2 at the top and the 1.75 here. It should have gone like this, so make sure you understood that. What's this? 144 divided by X. Because area of the print matter is 144. So length times width of the printed section has to be 144. So if X times Y has to be 144, isn't Y 144 over X? So the dimensions of your poster board are, what is that, 3.15 plus X, and 3.75 plus 144 over X. You okay with that? Now, this is a calculator problem. This is definitely on the calculator page of the test. So if you want to just do that, like that, it's fine. Your calculator doesn't care. It's fine. So if you type that in, hit graph, what are you looking for? Minimum, right? So let's see. Now my window is sort of messed up from my box problem, so I have to keep that in mind. Actually, it's not too bad. I think this happened yesterday. Did you get something that's kind of like a Nike swoosh? Kind of looks like that. If you're still struggling, my window, for my X's I did 0 to 50, and for my Y's, I just left it at 1500 from the box problem, and that seemed to work okay. Again, no one cares what you see. You just need to see a low point, you need to find a low point. So make sure that you've graphed enough of the picture to see a definite minimum, and then let's find the minimum. I got about 11. I got 10.998, so I'll say 11, comma, 238.30. Anybody else get that for your minimum?
Yeah.
Now, make sure you answer the question. Just answer the question. What was the question? What is the minimum area for the posters? 238.30 square inches. My last comment, and then I'm gonna just let you go. Yesterday, the question was different. Yesterday, it was all set up like this, looked like that, whatever. But yesterday, remember, the question was, what are the dimensions of the poster? So if that's the question, then you're gonna use your 11, and you're gonna plug it in. So one dimension of the poster would be 14.15, and the other dimension of the poster would be, I'd have to work that out, but 144 divided by 11, plus this. So make sure, after it's all said and done, that whatever you put in the answer blank is the answer to the actual question that was asked. Okay? Now, there is a lot of other review stuff in here, a lot. But we have just done twice the problems that are on the test. So you know where you feel uncomfortable.